Welcome to 5.3 Arcs. In this lesson, we're going to be talking about types of arcs and how to measure arcs. So I want to refresh your mind on what we talked about from semester 1, which was an angle. And this is a figure formed by two rays or segments that share an endpoint. So what does that mean? Let me draw one. I'll label this segment AB. And a second segment, let's call it BC. So you see, and together these form an angle right here. Let's call it angle 1. So this is a figure formed by two, in this case, two segments, and they share an endpoint. That endpoint is B, and a better name for it is the vertex. Vertex. And a way to remember it is that if you look at the angle, it looks like the letter V, which is the letter that vertex starts with. So that's how I like to remember vertex. So point B is the vertex. Okay, so remember in 5.2, we talked about chords, diameters, and radii. Those were straight segments for circles. Now we're going to talk about the curved parts of a circle, which are the arcs. Okay, so that was an angle, and let's get into what an arc is. An arc is a part of the circumference of the circle. Now let me remind you that the circumference is the distance around the circle. Okay, so if we were to start at this yellow point and we just walked all the way along the circle, all the way back to the end point, again, making a full circle, that would be the circumference. It's the distance around the circle. So this yellow part here, where we have two endpoints, that would be the arc. You can see it's only part of the circumference because the circumference is actually the whole distance around the circle. So an arc is only part of the circumference. Now, let's say we have a center C for this circle, and we drew the radius. Actually, let's draw it like this. We drew the radius, and the radius is a segment, remember, from the center to any point on the circle. Now let's draw a second radius. Let's do this radius. Oops. Hang on. Okay. Now what do you notice? Don't you see that these are actually two segments? Let's say AC and CB. Two segments that share an endpoint called point C or vertex. And because of this, they form an angle. Let's say that angle is 80 degrees. Okay? And, oops, I should not. Let's say we wanted to take this same radius, and let's say we wanted to move it a little bit more. Now what do we get? Again, these are two radii, or two segments, that share an endpoint, and so they form an angle. Now this angle is a little bit bigger, maybe 120. Okay? Now what if we just kept moving this radius all around, all the way until we overlap CB? Well, what would we actually get is 360 degrees. So there are 360 degrees in a circle. Why? It's just by convention. I don't really know why. I'm pretty sure it's by convention. But yes, there are 360 degrees in a circle. And that's going to relate when we talk about measuring arcs. So let's get into the types of arcs. The first type is the minor arc. This is an arc that is less than half the circumference. So you see this yellow arc with endpoints A and B. This is a minor arc. And remember, there are 360 degrees in a circle. What is half of 360? 180. So a minor arc is actually less than 180 degrees. Okay, so it's going to be less than half the circle, because the circumference is just the distance around the circle. Now remember, we had to label angles, triangles, segments. Now we also have to know how to label arcs. How do we do that? Well, we see it has endpoints AB, so we'd write AB and just a half moon or an umbrella on top. Okay, so now the second type is a major arc. This is an arc that is more than half the circumference, and it's created by the minor arc. Now, why do we say it's created by the minor arc? Well, do you see AB and the yellow part, that is the minor arc. And whatever is left over to cover the entire circle is called the major arc. So A, C, B, the orange part is the major arc. And you can see that is more than half the circumference or more than half of the circle. And what is half? Remember, half is 180 degrees, so it's going to be more than 180 degrees. So that's why we say it's more than half the circumference, because it covers more than half the circle, and it's created by the minor arc because the minor arc is less than half of the circle. How do we label this? Well, we'd have to say ACB and an umbrella on top. Now, why can't we just say AB? Because if we just had AB, if we didn't have point C, how can we distinguish from the major arc and the minor arc? We can't really. That's why we need the third point. So usually major arcs would have 3 points. Third type of arc is a semicircle. This is an arc that is exactly half the circumference. So that means it will measure exactly half, or 180 degrees. So those are the 3 types of arcs. Now we're going to talk about measuring arcs. So the first one that we talked about was a minor arc. How do we measure a minor arc? Well, it actually has the same measure as the central angle. What is the central angle? This is an angle whose vertex is at the center oh no center of I'm just going to draw a circle. And you can see in this picture we have 2 radii, the 2 yellow segments. They are connected to each other and they share an endpoint. And because of this, they form an angle. And you see that angle is 120 degrees. That angle is called the central angle. And you can see that the vertex is at the center of the circle. So we call it a central angle. So the central angle is 120 degrees. And you can see it actually encompasses the minor arc, which is the yellow part covering the circle. So the minor arc actually has the same measure as the central angle. So we would write it right here, where the orange is for the minor arc and the 120 in yellow refers to the central angle. Now, how do we label that? We would just write, if we had points, yes, arc AB is equal to 120 degrees. Now, how do we measure a major arc? Remember, we said the major arc was created by the minor arc. So to measure the major arc, it's actually 360 minus the minor arc. Why? Because remember, there are 360s in a full circle, and we said the major arc was created by the minor arc, so it does make sense that it should be whatever is left over. For example, if we had minor arc DF, and we said it was 120 degrees, then what is the measure of the major arc? So measure of DEF is 360 minus the minor arc, in this case it's DF. So what is that? 360 minus 120. So the measure of our major arc DEF is 240 degrees. And if we had a central angle and we drew the central angle, and we said that the central angle was 120 degrees, you can see that the minor arc is inside the central angle and the major arc is outside the central angle. Okay? Now a semicircle, we said it was always half the circumference, no more, no less. And how many degrees are in a circle? 360, so it should make sense that a semicircle always measures 180. So how do we label this? AB equals 180. So what did we learn in this lesson? We refreshed our memory on an angle, which is 2 segments or rays that share an endpoint. And we call that endpoint the vertex. And we related it to major and minor arcs. And we learned about 3 types of arcs: minor arcs, major arcs, semicircles, and we also learned how to measure those arcs.